Molecular basis of muscular contraction. Molecular mechanism is responsible for formation of actomyosin complex that results in muscular contraction, excitation, contraction coupling, role of troponin and tropomyosin, sliding mechanism. Molecular mechanism responsible for formation of actomyosin complex that results in muscular contraction, excitation, contraction coupling, role of troponin and tropomyosin, sliding mechanism. So first the excitation and contraction coupling. Excitation of muscle fiber by impulses passing through motor nerve and neuromuscular junction. From there, generation of action potential in muscle fiber. Spread of action potential via transverse tubule T tubule. Entrance of action potential in cisternae of sarcoplasmic reticulum. Entrance of action potential in cisternae of sarcoplasmic reticulum. Release of calcium ion from cisternae. Movement of calcium ion towards the actin filament. Contraction of the muscle fiber. So, excitation, contraction coupling, excitation of muscle fiber by impulses passing through motor nerve and towards the neuromuscular junction, a generation of action potential in muscle fiber, spread of action potential via T tubule, entrance of action potential in cisternae, release of calcium ion from cisternae, movement of calcium ion towards the actin filament, contraction of the muscle fiber. Sliding mechanism and formation of actomyosin complex. Sliding theory. Sliding theory explains how the actin filament slide over myosin filament and form the actomyosin complex. Release of large amount of calcium ion from cisternae of L tubules, release of large amount T tubules, release of large amount of calcium from the cisternae of L tubules itself, long tubules. That binding of calcium ion with troponin, change in position of troponin, pulling over tropomyosin molecule away from the F-actin, exposure of active sites of F-actin, attachment of myosin head to the actin, power and tilting of myosin head and dragging of actin filament, detachment of myosin head and returning to original position, attachment of myosin head to new active site, attachment of myosin head to new active site of F-actin and dragging of actin filament, repetition of these actions. Movement of actin filaments of both sides towards each other and formation of actomyosin complex which leads to the contraction of muscle. Once again, release of large amount of calcium ion from cisternae of L tubules, binding of calcium ion with troponin, change in position of troponin, and pulling of tropomyosin molecule away from F-actin, exposure of active sites of F-actin, attachment of myosin head to actin, power stroke, tilting of myosin head and dragging of actin filament, detachment of myosin head and returning to original position, attachment of myosin head to new active site F-actin and dragging of actin filament, repetition of these actions. Movement of actin filaments of both sides towards each other and formation of actomyosin complex, contraction of muscle. That's it.